them up. What value of x would make this equation true? David? 3. Very good. So 4. Do you guys agree that 4 to the third power is also equal to 64? So x is therefore equal to 3. So what we are doing today is we are solving exponential equations like this one, okay? Now, there are some examples where it's very easy, and there's other examples where it's a little bit like a puzzle, okay? I love this lesson because, like, I love puzzles, okay? But it's kind of like a puzzle in terms of, like, you have to figure out what piece belongs where, okay? And you'll see what I mean by that. How I want to teach this lesson, guys, I want you to write down on the right side of your paper before we start anything, I want you to write the equation 3 equals 3. Do you guys agree that that statement is true? Yes. 3 is the same number as 3? Mm-hmm. 3 is the same value as 3. Agreed? Okay. What if I squared one of them? If I squared the left-hand side, is 3 squared equal to 3? No. What would I have to do to the other side so that they would be equal? Square. So 3 squared is equal to 3 squared? You sure? Yes. What is 3 squared? 9. And 9 is equal to 9. Do you guys agree with that? Okay, what if I changed it a little bit further and I wrote 3 to the x power is equal to 3 to the second? Would you guys be able to tell me what x needed to be equal to?
Yes.
What would x have to be equal to?
2.
How did you know that x had to be equal to 2?
Because they have to be the same number.
They had to be the same number because what was the same between them? The 3. Highlight the 3. What is that 3?
The base.
Your base. So today's lesson, the most important part of the entire lesson is that we get these bases to match. Because once they match, it's easy. It's like a puzzle, okay? But in order to get them to match, that's going to be the most difficult part of today's lessons. Now, the first examples are very, very trivial because all of the bases are already the same, okay? But later on in the lesson, you're going to see where you're going to have to use a little bit of your brain and be like, okay, what is the base that would make these equal, okay? All right, so check it out. One thing that I need you guys to read in this property of equality for exponential equations, when we set those exponents equal, is that the same base must be present, your b cannot be equal to 1, and your exponents, that's what you're setting equal to each other, okay? Now, let's think about this. The reason that b cannot be equal to 1, remember, b represents your base, hence b base, right? Let's say we had 1 to the x power equals 1 to the 5th power. Does x have to be equal to 5? The answer is no. What is 1 to the 1,000,000th power? It's 1 times itself a million times, right? It would still stay as what? 1. Is that the same as 1 to the 5th power? Yes. So what values for x could I plug in that would make these equivalent? Any value. So do you see how x has unlimited possibilities? So this is an example where x is how many solutions? Infinitely many, okay? Write that down. So this trick only works when your b value is not 1, okay? And the examples that we're going to look at, b can also not be negative, okay? Now, this is a little bit higher level thinking. So if what I just said went completely over your head, don't worry, okay? You're not going to see where b is equal to 1. It won't happen, okay? But I just want you to understand why b cannot be equal to 1, okay? All right. So let's take a look at our first example. In this first example, I need you to write down every single step that I do. In the future examples, you don't have to write down all your steps, okay? But I need you to do this checklist for at least the first example. Step number 1 for all of these examples is get the same what? Base. That means that base for both of the exponents should match. Do they match right now? What's both of them? They're both 3. So let's put check marks there. We've satisfied step number 1. Once you get the bases to match, step number 2 is you say, okay, my exponents should be what? My exponents are the same or equal, right? So if my bases match, my exponents are equal, set up another equation. That other equation is going to involve this exponent and this exponent. So circle them. What would happen if I set my exponents equal to each other? What equation would I have now? X plus 1 equals, what was the other exponent? 5. Is this an equation we know how to solve? Yes. So step number 2 is set your exponents equal. Step number 3 is the most easy of all of them. It's just solve it. Can someone who remembers how to solve something like this? X plus 1 equals 5. Matthew?
So you subtract 1 to both sides, and then you have 4.
X equals 4. Very good. Give it up for Matthew. Okay, so do you guys agree? At first glance, this is something we've never seen before, but did we turn it into something we can absolutely do? That is our goal for today's lesson, okay? Now, the puzzle part comes later on, okay? And we'll get to that. Yes, Michael.
So, couldn't you also just do 5 minus 1 equals x?
Yes, but do you see how setting it up, not all the equations are going to be that trivial, okay? See how setting it up, we are just doing 5 minus 1 equals x, okay? Make sure you're following the steps, though. So you're at least writing me this step, x plus 1 equals 5. Any other questions? That was a good question. Okay, example B. All right, what was step number 1? Don't look back. Try to remember it. What was step number 1, Matthew? Bases need to be the same. Are the bases the same? Yes. McCarvin? No, there's a line. What do I do after that? Make the exponents equal. But what's the exponent over here, Alec? There is no exponent. So what's technically there? 6. It's a 1. Remember, what is 6 to the first power?
6.
6. So if I changed my equation at all, it's still 6, right? 6 to the first power is still 6. Do you guys agree with that? Mm-hmm. So, now I can set them equal to each other. The exponent on the left is what? 1 equals the exponent on the right? 2x minus 3. Juliana, do we know how to solve something like this? Like, could you actually solve this? Yeah, totally. Who wants to take a shot at solving this? McCarvin?
So what you would do first, you would add 3 to both sides.
Okay. Why?
Why?
Yeah.
Because you're trying to get the variable isolated.
Excellent.
Then you would have 2x equals 4.
Like this?
Yes.
Okay.
And then you would divide both sides by 2.
Okay. I'm going to do it so I don't confuse myself. I would write it as 4 equals 2x, just because the 4 would be on the left side. But you are absolutely right. You divide by 2. You get what, McCarvin?
Then you would get 2 equals x.
There we go. 2 equals x. Easy? Once you set it up, you have to remember your rules. And what is always step number 1, guys? The bases need to match. If the bases don't match, don't just blindly set the exponents equal, okay? Let's do one more and then you guys are going to get set loose. Before I do that last example, questions. Is anything on your mind that you wanted to ask me? Andrea? We'll get there. We'll get there. I love where your head's at. Did you guys hear a question? What if the bases are not the same? And that's my favorite part of the lesson. But we'll get there. Okay, that's example 2. Any other questions? Okay, C. 10 to the 3x equals 10 to the 2x plus 3. Kira, go for it. Good. Uh-huh.
Which will be 3x equals 2x plus 3.
Good.
And then you can add 2x to the other side.
Ooh.
Or subtract it.
Subtract it. Very good. Why am I going to subtract it, Kira?
Because it's already positive.
Excellent. It's a positive 2x. Okay, what do I do after that?
You can get x equals 3.
Very good. X equals 3. Guys, give it up for Kira. Good work, Kira. Guys, that was excellent. She explained every single step. Are there any questions on this example? Okay, my challenge for you is do D, E, and F. See if you can get all 3 correct without using anyone in your group. Go. Did anyone for D get x equals 3?
Yes.
Okay, can anyone walk me through it? Go ahead, David. Love that.
And then after I roll 2x, bricks, and then equals 6.
You're so smart.
Then I divide it
Then you divide it by 2. What was my answer? 3. Very good. Guys, give it up for David. Okay. E. Did you get x equals 1? Segi, walk me through it.
So first I checked out my bases were the same and they were.
Uh-huh.
So then I get the exponents and I put 2x equals x plus 1.
Mm-hmm.
I minus 1x on both sides,
Okay.
which then gives me 1x equals 1. Divide the 1x on both sides and then you get x equals 1.
Divide by 1 on both sides. Okay. Do we have to divide by 1? No. Because remember, Segi, I'm not saying you don't have, like, you could absolutely divide by 1, but 1x is the same as just x, right? So we already solved for x. It's just x equals 1. Very good. Guys, give it up for Segi. Give it up for Segi. All right, for the last one, F. Alec? X equals -1. I believe that's correct. Can you walk me through it?
They do the same thing, like 3x plus 5 equals x plus 1.
Why am I allowed to do that, Alex?
Because that's the 7s were the same.
Very good. My bases were the same.
And you move the x to the 3x, subtraction.
Okay.
Move the 5 to the left.
By doing what?
1 minus 5.
Yep, you subtract 5, so we're going to get 2x plus 5 equals 1. Subtract 5, 2x equals -4. Well, what's 3 minus 1? Then you divide it by 2, right? Do you see how it should be x equals? -2. I think you said -1, right? But the correct answer is -2. Close enough, okay? Make sure that you got x equals -2 and not -1. Guys, give it up for Alec. Good work, Alec. Okay, now for my favorite part of the lesson is when the bases do not match, okay? Now, how we're going to do this one is we're going to break it down into steps, okay? And I want you to write down these steps over on the right-hand side, okay? So let's say we had the number 4, right? And we wanted to set it equal to a base of 2 with an unknown power, okay? What would 4 be the same as to match 2? Karen? 2 to the power of 2, okay? Let's say we had 27 and we wanted to match it to 3 to some unknown power. What number would have to go in that box? 3. Why, Christian? 3 times 3 times 3 is 27. What if we had 8 and we wanted to match it to 2 to some unknown power?
4.
It would be not 4, 3. Okay? So guys, this is a skill that we are going to get better at, okay? And that is what we have to do for these kinds of problems. So the bases are not going to match, but what we can do is we can force them to match, okay? So take a look at the first example. We have 5 to the x equals 125. Now, I'm going to walk you through a process that I want you to follow. Take the smaller base. Which one is the smaller base? 5. Can you raise 5 to some power to be the same as 125? What power? The third, okay? So watch this. Leave this guy the same. This guy you don't touch. 5 to the x equals, you're going to write 125 as 5, and you're going to put your box. What did you guys say belongs in the box? The 3. So you put a 3 here. Do my bases now match? Bingo. What can I do with my exponents? Do what thing?
Put them into the equation.
Yeah.
Put them into the equation and put what in between them? An equal sign. So x must be equal to 3. Okay? Yes? I don't know.
Oh, David does. David's a good guy.
Thank you, David.
David, you're so
David's
nice.
such a good guy.
Any questions on letter A? This is new, people. Ask me. Okay, next one. Letter B. Karen?
Because you need 4 and 2 to be the same,
Uh-huh.
you're going to take 4 and you're going to 2 over, power of 2 equal to x minus 2.
She is very close, okay? So watch. She said, okay, 2 is my smaller base. Do you guys agree? And 2 raised to the second power, do you guys agree, is the same as 4? But what was 4's exponent? X. Do you guys see that? You have to raise this new base to that exponent, to the x power. So look at this closely. What Karen's doing is she's saying she did it absolutely right. She said 2 is my base. I want 2 to match 4, right? What exponent belongs on a 2 that it would be the equivalent of 4? A 2. Do you guys see that? So 2 squared, this is just 4. Do you guys agree?
Yeah.
And this is just 4 to the x power. So have I changed the left-hand side at all? No, I've just rewritten it in a way that I can use the bases now. Okay? Take another look at it. I want you to ask questions because this is the puzzle part that I love. Natalie?
What do you do now? Like after you get the
I'll get there. I'll get there. Any questions getting to this step? I love that you asked that though. Okay. What do you do when an exponent is raised to another exponent? Multiply them. What's 2 times x? So let's write this again. It's 2 to the 2x equals 2 to the x minus 3. Does this look familiar now?
Yeah, boy.
Caitlin? Where did I get the what from? Which x? Oh, because 4 was raised to the x power. Okay? This exponent over here needs to go outside your parentheses.
Mr. Jurko, I have a question.
Yeah, Mia.
Are you posting this video?
I am, of course. Okay. So I have the same base. Do you guys agree? What do I do when I have the same base?
We know what we do. Check.
Yeah?
You can subtract the exponent.
Not yet.
Put an equation.
Put in an equation where the exponents are
2x equals x minus 3.
equal to each other. 2x equals x minus 3. Now, Karen, you are correct. What do I do?
Now you can subtract. So u minus x
Mm-hmm.
would give you x equals
Negative 3. That's it. X equals negative 3. You guys, I know this is new. It's a puzzle. It's fun. I literally love this lesson, okay? You will get better at doing these puzzles, okay? Were you like super good at doing like crosswords when you were an infant? No. Like you had to practice, right? This is just like practice, okay? It's a puzzle. You have to put the pieces together. Let's take a look at C. Now, I said always use the base that is what? Smaller. So 9 is smaller. Do you guys agree? But can you raise 9 to a power to give you 27? No. What's 9 squared? It's already 81. Do you guys agree? So let's try something else. This is an example. Put a star next to it. We're going to have to change both bases. Okay?
Yeah.
Oh, Brayden, why 3? All right, so Brayden said 3. 3 to some power and 3 to some power. Okay? Now, remember, this 9 was raised to the x plus 2, so put x plus 2 there. And this 27 was raised to what power? So make sure the x goes outside your parentheses. Now, make them match, okay? What's 0? And that's a box, Mia, not a 0. Okay? So 3 to what power is the same as 9? Not 3. 2. 3 squared is the same as 9. 3 to what power is the same as? 27. It would be 3. Yes.
You get the 3 and not the exponent.
That's the puzzle part, Segi. That's the puzzle. So what Braden noticed was he looked at this, he's like, 9, I can't square it and get 27. Do you agree? So he had to look for another base that was similar between 9 and 27. A root, right? Do you agree that the square root of 9 is 3? And the cubed root of 27 is 3? So we're going to rewrite this as 3 squared for 9 and 3 to the third power for 27. That's the puzzle part, okay? And that's the part that I want you guys, it's not going to click right away for everyone, but you will get better the more you practice and try. Very good. Yeah, Caitlin.
Why do you have to change both these?
Because, David, you want to answer that? Go ahead.
Because you can't square root the 9 to 27.
Yeah, because 9, do you agree that 9 squared is already larger than 27? It'll never match. So we have to change both of them so that they will match. Now my base is going to be what for both of these? 3. Now, don't forget, when you multiply these exponents, what needs to happen here, guys? On the left-hand side. It's going to be 3 to what power? 2x plus 4. How did we get plus 4? Did we not distribute? Do you guys remember distribution? Okay, so it becomes 2x plus 4 equals, what do we got on the right-hand side? 3 to the 3x. Okay, if it helps, draw your arrows indicating multiplication. All right, do my bases match? Okay, what can I do when my bases match, guys? Set up an equation and solve it. Okay, so I'm going to set 2x plus 4 equal to 3x, and I'm going to go ahead and solve this guy. Who wants to solve it? Natalie, go for it.
So first I lined all the exponents up, which is 2x plus 4 equals 3x.
Uh-huh.
Then I did the easier number to subtract. I did minus 2x to both sides.
Okay.
And I got x equals 4.
And you got 4 equals x. Very good. Guys, once you finish setting it up, is it not a very easy equation to solve? But that's going to be the hardest part, is the puzzle part. Figuring out what base you can use to represent both of the original bases. Yes?
Is this lesson going to get any more complex?
No, this is the most complex kind of problem you'll see. Okay? Yes, David.
Wait, how do we get 3x minus 2x? Oh, x is the 1.
Mm-hmm. All right. Let's try another one. Yeah, Emma, did you have a question? Go ahead.
Just to make sure, you could break down one of the numbers and make so that way both things could be the same.
Yes. Mm-hmm. Mm-hmm. D. Start with which base?
4.
The smaller one, right? 4. Is there a way to get 4 to be 256? It's 4 to what power? 4 to the 4th. If you don't believe me, multiply it out. Do 4 times 4 times 4 times 4. It will give you 16 times 16. And if you trust me, you do. If you don't, multiply it out. You get 256. So I'm going to write 4 to the x equals what? 4 to the 4th. My bases match now. What do I do with my exponents?
You make an equation?
So x equals 4. McCarvin,
You don't have to check my work, right?
what do you mean?
With the X, you don't have to
Like the 4.
Oh, plug it in. You don't have to. You can if you want to make sure that it works.
Mr.
Mm-hmm. Yes.
So on those where it's like a number x equals a whole number, I just divided the larger base by the smaller base, and then divided that answer by the smaller base. I got the same answer. Oh. So 256 divided by 4
Is 64, right?
64, then
Yeah.
divide that by 4 again.
No.
I just kept
Because 64 divided by 4 would give you 16.
as into the power.
Oh, and then you figured out it had to be the power of 4. Oh, I like that. Did you guys hear what Michael did? He took this 4 and he said, okay, how many times can that go into 256? So we wrote 256, divided it by 4. He got 64. Then he divided 64 by 4, and he got 16. Then he divided 16 by 4, and he got 4, okay? You can absolutely do it that way. I like that, okay? Any other ways that you guys notice to do these problems?
Yeah. Well, I knew that
What carbon knows?
It's gonna be
Teach
even.
that shit.
No, I just did the same thing as Michael.
Same thing as Michael?
Two numbers.
Okay.
I
Mhm.
knew that the answer's gonna be an even number.
Yes, because anytime you have an even number here, its root must also be even, okay? All right, let's look at another one. Let's look at E.
You know what we gotta do for this?
Okay, what do I do?
The hard thing.
McCarbon?
You need to make the bases the same.
Okay.
And the way you do that, you would make the base on the right side 3 to the third. Well, you'd make it 3 to the third power.
So write it like this.
And then
What is 3 to the third, McCarbon?
wait, no, I'm tripping. 3 to the 3 squared.
3 squared is over here.
Whoa, wait.
A 3 squared is correct, but you're...
You put parentheses.
No, it's on the wrong side. Where was the 9?
Oh.
On the left, right? So this becomes 3 squared, but we're raising 3 squared. What was 9 raised to? The 2x. Equals, do we touch this guy on the right?
Yes. But no.
No, because what was its base originally? 3. Is that going to match? Yes, so we leave it 3x minus 6. Okay? What do I do now? Not yet. You can't set up an equation yet. Caitlin. Why did I put 3 squared? What is 3 squared, Caitlin? But you put it on the other side? This one's already 3.
You gotta distribute
Distribute the parentheses. What do you mean by distribute? What operation there, Michael?
multiplication.
All right, what's 2 times 2x?
4x.
4x. So 3 to the 4x equals 3 to the x minus 6. What's my equation with the exponents? 4x equals x minus 6. Someone solve it. Go ahead, Caitlin.
You subtract x, and then you get 3x equals -6.
Mm-hmm.
Divide by 3, and you get x equals
You're so good. X equals -2.
This is easy. I'm working on it.
You guys, it's a puzzle. You gotta figure out the puzzle, okay? Take a look at the next one. Take a look at the next one and see if you can figure out what the puzzle would have to be here, okay? Now, I'm gonna tell you straight up. What's 4 squared?
No.
It's not 8, it's 16. Are we gonna be able to have a base of 4 for both of these?
No. Basic
No.
two.
So now we're gonna have to change both of them. Make the base what, David? 2. Watch this. Write a 2. Write a 2. We have to raise a 2 to some power. It's going to be raised to the 3x. The other 2 to some power, it's going to be raised to the x plus 1. Who said I'm done? You gave up?
No.
Yeah. Hey, no. It's the worst attitude you can have. You got to believe in yourself. First and foremost, you got to believe in yourself. Yeah, Caitlin. Why can't you do 4 squared? Because is this 16? No. You have to get them to match. If this was 16, sure, you could do 4 squared. Okay? But this is 8. So 2 to what power matches with 4? The second. 2 to what power matches with 8? 3.
I'm on fire.
So watch. What do we do with these numbers?
You better distribute that.
Multiply them. So it's going to be 2 to the 6x equals 2 to the 3x plus 3. Do my bases match? Guys, I have to save questions for the end, okay? Because I'm working through this problem. Set my exponents equal to each other. 6x equals 3x plus 3. Subtract 3x from both sides. You're going to get 3x equals 3. Divide by 3. Divide by 3. X equals 1. Before you ask me a question, look over it. See if you can answer that question yourself. I want you guys, honestly, to have a discussion in your groups. If you don't understand something, ask your group. Then we're going to talk about it as a class. Go. 5, 4, 3, 2, 1. Okay, what questions do we have for me now? after you've talked in your groups? Was that helpful for you guys to talk it out?
Yeah.
Kind of.
You guys have no questions for me.
You didn't talk.
Oh,
I included Natalie in my group.
okay.
We also included Natalie.
All right, hey, we have to move on to the last example. It's the exact same, just a little bit different, because we're going to be dealing with negative exponents. Now, remember,
Oh, that means you have to do that.
negative exponents is just 1 over that base, okay? So, let's take a look. This isn't harder.
It kind of is.
Trust me, it's not harder. Trust me, it's not harder. Which one is the smaller base? Now, I want you to only look at the numerical portion. 2 or 4? 2. So let's try to write everything with a base of 2. So it's going to be 2 here, 2 here. Put it in parentheses. Now, what would make 2 match a half? What exponent? Natalie? A negative what? 1. 2 to the negative first power is 1/2. What would make this 2 match the 4? What exponent?
2.
A 2. Take it one step at a time. What do I do with the negative 1 and the x, guys? Distribute or multiply. What's negative 1 times x? 2 to the negative x equals 2 to the second. What do I do once my bases match, Karen?
You divide it by negative.
No, before you even do that.
Oh, well, you have to write the column, so negative x equals 2.
Good, I'm setting my exponents equal to each other. Then what?
Then you divide by negative.
Divide by negative 1. What's 2 divided by negative 1? Negative 2. Yeah, as long as you understand it.
As long as you understand.
Let's see one more, and then I'll take questions. Take a look at B. Okay. I want you to look at the numbers, okay? The actual values, not the 1. Not the 1 over 64. Guys, which one's smaller, 4 or 64?
An interruption. Chloe, Alvaro,
One on the left. No, it's going to be 4 to the x plus 1. Do not touch it. Equals 4 to some unknown power. What would you have to raise 4 to become 1 over 64? McCarvin? No. Colin? No. Negative 3. Do I have the same base?
Yes, sir.
What can I do?
You know what you do.
You make an equation, set these guys equal to each other. X plus 1 needs to equal negative 3. Subtract 1, x equals negative 4.
Can we do the next two on our own?
I would love if you guys tried the next 2 on your own. We will discuss them. Okay, the answers are written on the board. See if you did okay, if you got them right. If you didn't, talk with your groups, figure it out, and answer that exit ticket. Turn these in when you're done.